applying our own acts and nacks on top of that, acknowledgements, and on top of UDP, we can make that a reliable protocol. And we can also do clever things like bundle lots of messages together so that, for instance, we can make best use of the actual bandwidth. And also, by having our own proprietary protocol rather than using a protocol like RMI or IOP or something like that, or relying on TCP, it means that we don't have to rely on TCP timeouts, for instance, so we can react very quickly to environmental changes. So if a process or a server fails, we can react very quickly to those kind of issues which might occur. The other thing is that Coherence only relies on a Java virtual machine. There's no native code that comes with Coherence to actually cache data. So you can form a Coherence cluster across Java Standard Edition, a JGB container. You can use Spring with it. It really only uses Java. So the only thing we actually require is a Java virtual machine. So what is Coherence? You know, I've told you roughly that are Java programs that talk to each other to provide a virtual pool of memory which we can store caches in, or lookup tables of sort of key value pairs. Because that's really what a cache is in Coherence terms. It's just a lookup table with key value pairs. So what is it if you download and install it? Well, actually, it's just a bunch of Java libraries. So it's quite small. It's about 20 meg. If you download a Coherence, we don't depend on any third-party libraries. So that means when you download it and you start it up, you don't have to download Log4j or other Java libraries. Everything is there that you need to run straight away. But that doesn't mean we don't integrate with other third-party libraries. So you can plug in Log4j, for instance, if you want to use that for your logging. If you're using Spring, we work with Spring. If you're using Hibernate, we have plugins for Hibernate. So we work with all the third-party and open source libraries, but we don't depend upon them. So we're not tied to their timeline. We also work with .NET, so if you're a .NET customer, you can write all your applications in VB.NET or C#, and then you can access information held in a Coherence cache using native code from the .NET side. So, for instance, on a .NET client, you don't have to install any Java. You just install an MSI file, which adds some DLLs to the general assembly cache. Or if you're a C++ developer, you can write a Coherence client using pure native C++ libraries, whether it's in Solaris, Linux, or Windows. We provide native libraries for all those clients. And again, for each of those, we don't depend on any third-party libraries either. The thing about Coherence is that the API to it, it's a programmatic interface. So effectively, if you're a Java programmer and you have a cache that you've written yourself, typically people use a map, so a map of key value pairs. And the interface to Coherence is identical. So if you're putting your data at the moment in a map and you decide I want to use Coherence for the features which I'll explain later, then it's very easy to do so, because we basically implement the map interface, but we do some clever things under the covers to allow your map to grow very large, to be spread across a number of computers. If you're a .NET developer and you're using an iDictionary interface, then again you can plug in Coherence, and we provide a way of having your iDictionary spread across a number of computers and made resilient, etc. You also don't get remote exceptions, or very infrequently, with Coherence, because Coherence has features built into it to enable it to recover when things go wrong. On the one hand, Coherence is a very simple product. It just provides a map interface. The clever things it does is distribute that map and spread it out across a number of servers. But the other clever thing it does is make it resilient. So if there's a failure, if a process fails, if a server fails, we take care of that and recover seamlessly, so the client doesn't need to know or care about how that happens. And that's why you don't get remote exceptions, because we don't expect the client to deal with that. That's what Coherence does. So I've talked about using a map. Now, the interface really to Coherence, if you start using it, and I'll show you a small code example later on, is what we call a named cache. So say a cache is a lookup table based upon the map API. And so when you put data into a cache or get data out of a cache, it's typically you'd use a named cache. And there are some sort of similarities between a cache or a lookup table and a database table. So for instance, the key in a lookup table is equivalent to a primary key, and the value is sort of equivalent to a row in a database table. Typically you'd have the same thing stored in the lookup table, so you wouldn't have a lookup table with trade data and stock data or something. You typically have one thing in one cache and another thing in another cache. You can have as many caches as you like, so you can have hundreds of caches if you want, and all those caches can be cross-linked by having, in the value in one cache, you can have the ID or the key for a value in another cache, and that's how that, I suppose, is equivalent to a foreign key. Caches are dynamically created, so if I'm a client and I say, give me a reference to the cache test or trades, for instance, give me a reference to the trades cache. If the trades cache already exists, Coherence will return a handle back to that, so you can access the information in that cache. If the trades cache doesn't exist, then Coherence will dynamically create that and then return you a handle. So it creates it on the fly if it doesn't already exist. The keys and the values held in caches or lookup tables can be any object. So they don't have to be any particular type. You can create your own objects and make those the keys and the values. It can be any object you like, and it can be a hierarchy of objects. It can be a binary string. It can be an integer. It can be a string, etc. There's really no restriction. And although it's similar to a relational database in the sense that you can have two caches linked together where the value in one cache contains the ID for a value in another cache, they're not identical to relational database tables. So I'm drawing similarities, but they're not identical. So what does a Hello World program look like? This is pretty much the only code. There's a few other small snippets of code, which are in Java, but the code for .NET or C++ would look very similar. Here we've got a main program for a Java application. We get a handle to a named cache. So you look up a cache, you give a cache a string name, so in this case it's called test, and the named cache object you get back implements the map interface. So you can just treat it like an ordinary map. You put values in, you can get values out. Where those values actually exist is irrelevant. They can be spread on other computers in a completely different location. The client doesn't need to know and doesn't need to, if data moves around, it doesn't care, it doesn't affect it at all. When a client actually gets a cache, it effectively joins the cluster. So by joining the cluster, I mean that it actually it's sent information about if data moves, so it knows where that data's gone to. But from a programming perspective, that's completely transparent. So what types of lookup tables or caches can you have? Well, you can have a local cache. So in Coherence, you can create a local cache, which is effectively the same as a map that you would create in a Java program locally. You can create a replicated cache. A replicated cache is where you have a number of servers or a number of processes with the same copy of the data everywhere. So if I have two servers with each of them has a Coherence application running on each of them, talking to each other, and I change the data on one server, and I'm using a replicated cache, then any changes in one place will be replicated to every other Java program in the cluster. So it's okay if the data is relatively small, the volumes are small, or the data's pretty much read-only. And the reason for that is with a replicated cache, all the data has to fit in every single JVM. So it has to fit on the heap in every single JVM. So if you're running on a 32-bit operating system, then you only have 4 gig maximum that your process can actually take up. So your cache, if you're using a replicated mechanism, can only be a maximum of 4 gig and probably a lot less.